So the talk is about estimating the ecosystem service value of wetland and marshes in terms of flood protection. And we know about storm surge and how it's causing damages all over the world, including United States and also the Mid-Atlantic region of the US. And it's expected to rise with climate change and more increasing population in the coastal areas. And at the same time, we are seeing that sea level is rising, that is also causing marshes to move inward or landward or convert to mudflat or sink in the sea. And that thing, people are these days thinking about, hard structure have long been used, but now these days, nature-based flood system or flood defense, which is wetland and marsh, as they can attenuate the storms and waves from flood. So people are thinking about whether to apply this in terms of flood protection. And this rates, the way the wetlands and marshes reduce the surge varies with storm locations and topography and other features. And at the same time, the service varies with the population and the property nearby. So in this study, we try to find the value of the ecosystem service of wetland and marshes in terms of flood protection. To do so, we did the study in the coastal counties of Chesapeake Bay in Virginia and Maryland, and we used computer models, which is ADCIRC+SWAN, that uses computes the water level and waves and intensity for storm surge. And we simulated 5 storms from high to low intensity wind intensity for the Chesapeake Bay that happened or occurred in the past 20 years. And we simulated the flooding for 2 different scenarios. In one scenario, we have all the wetlands kept as it is, and in one scenario, we took out all the storms. So there's one scenario which is with wetland, and the other one is without wetland. And what we did is we computed the flood, and then we converted the flood to property damage by using depth damage relationship. And then the difference between these 2 scenarios for these 5 storms, we see that is, the damage avoided by wetland is the value of the service of the wetland in terms of flood protection. So as we found out, in terms of flooding, there would be a 37 to 75% of increase in flooding if there were no wetland in these areas. And also, when we found out the difference, we divided it by the total wetland area. In that terms, we found out the value of wetlands, or the per kilometer square value of wetland in terms of like productive ecosystem service. And we found out that the value could vary from 0.1 million to $20,000. And when we divided the total wetland value by the flooded wetland, we found out the value is increased more, which is 0.4 million to $65,000. And the total value for different storms, as we can see that the value is varying. The value of the protective ecosystem service is varying in terms of storm, but still, the important feature here is the values are higher when the storms are worst. So the take-home message here is the value of wetland ecosystem service in terms of flood protection could vary from $55 million to $454 million. And then the value is increasing with higher or stronger storms, meaning that the value would be more valuable with climate change. And I think that's how I'd stop my talk.